All right, good. For this chart or this line of code is quite important. It's a logical diagram in based on the logic here. Next one, all right. So you do need to create a single loop that is no negotiable. So no matter how, you do need to have it, right? And the I increments here. So basically now you create these, right? And then you want to control these stuff. And logically speaking, you do need to declare, right? So now you need to declare left and right? So you can simply call that L. L is basically always one, I plus one, right? And integer R is always from the negative direction, so -1 here, right? Okay, so this is something about the logic here. Now, next one, I guess you need to define a formula here. So x plus y, x plus y and a plus z equals 0, right? Okay, and you do a little manipulation that is basically 0 minus y plus z, right? Okay, pretty straightforward. And you just declare x equals what? Negative or 0 minus nums of r, right? Okay, so, and this one represent the sum of these. Okay, this one represent the sum of these. Next one is you need to do a while loop here. The while is while left less than equals to right, right? Okay. If that is true, you're going to loop through it. So this is actually you are executing the what? This logic diagram here. But making sure x is basically these, right? So x is these. So the current one is the opposite. So therefore, your first thought is, okay, so if x is equivalent to nums of L and plus nums of R, right? And apparently this one's going to be R, this one's going to be L, right? Okay. If this is true, that simply means what? That simply means it is going to be it find itself, right? It find itself. That means if you add them together, it's going to be 0, right? Okay. Or yes, okay. Therefore, you need to create a vector outside here. So this is a vector, okay, vector, and this is going to be this, right? Okay, you can call that a box here, right? If that is true, you are going to have you want to push back, right? Push back, and you're going to push back what? You're going to push back nums of I first, okay? And I'll just copy and paste here. So these ones are going to be L, and this is going to be R, right? And right away, whenever you have these three items, you need to sort, right? So basically it is a sort, and that is going to be nums and the comma, this is n, right? Okay, so you need to also sort box, and this is box period size, right? Okay. And however, in order to have the optimal solution, you do need to sort the original array, and that is going to be these, right? Okay. And the time complexity of these is n times log n, right? Okay. And there we go, we have that. And then it's going to be, we're going to basically check if it is already, if it's already in, the rest, right? Okay. So first of all, we need to use a for loop, right? So for auto, and this one is going to be item for item, okay? In where? In box, right? Okay. And then we need to traverse it, right? So this one is going to be result, okay? Result period. This is a find, right? Find. This is what? Result period. Find. What is that? Okay. Test. Where's the test? Test is basically the set, right? So test period find box. And if there's no such data, and I guess we are added to the test. and then do some trick, right? Okay, there we go. So there we go. So this is going to be test period find, and right here, and equivalent to box period end, right? If I remember correctly. So this is find item. Okay, let's check it out here. So find box. Okay, so this is find box, but sub. Okay, and for this one, but why we need this sub here? I guess probably it is redundant. Maybe did we use any sub here? Okay, sub is this one test period end. This is test. This is a test here. Okay. If this is true, we're going to, I think we're going to have a bool, right? Boolean here is going to be is seen. All right. I guess first of all, it is going to be true, right? And if that is true, we're going to, now this is set, right? So box, no test. Test the period push, right? That's insert, and we're going to insert what? We're going to insert we're going to insert a box, definitely, yes. And then scene, we turn that into false, right? Okay. And right here, if scene is false, that means we didn't see it. So we add, so for else or res period push back, we're going to push back, or we're going to push back box, right? Okay, there we go. So for this part is going to be very identical to this. We have out2 if test period. Test is basically is a set, right? Set, find the box all the way to the end, test the end to the end, and we turn the scene into false. And if the scene is a false, we add that in, right? So we do have these little algorithms here. Test the find the box and equals test to the end, right? So for this part, I guess, this part is it basically you just need to memorize it, right? So if you have, I mean, it takes a time to memorize it. So because I mean, it's like a language. You do need to use it every day. So in order to memorize it, but whenever you memorize it, so this one, okay, it's just the memorization. There's no algorithm background required. So the easiest way, I guess, you just turn it into English. So test, I want test to find box and something equals all the way to the end. If there's no return or no results, that means there's no such data. I'm going to add it in, right? Okay. So, and something like that. So for these different people have different ways to memorize it. So this is one way here. All right. And then we implement that here. And later on, so now let's maybe return res here. So let's press run button. So let's see what is going on. So sometimes the first try may have a little problem here. So sort nums. Okay, we have sort. Wait a second. What is we have the sort. Oh, we need, okay, so this one is the begin. And this one is a nums period end, right? Okay. So for this part, it is it's okay, okay, because it's just the syntax stuff, and this one is going to be end. All right, and then let's press run button here, and let's see what is going on here. Now we have that scene is false, is scene, is scene. So for this, I usually want to is capitalize S, so can be a bit easier to see. All right, okay, is seen. All right, so let's press the run button to let's see what is going on here. We still have something here, so I guess these, oh, all the way down there. How do I best make it looks a little bit better here? So this one, oh, apparently I need to comment this one as well. And then let's run this code one more time to see what is happening here. Should have a little stuff here. Expect a this one. Okay, I do have this one. Let's see. So in line, what is this line here? Solution. Okay, I don't have that. Public. And these. Yeah, why don't I have these? Or there's oh, I don't think this one. And what if I remove that one? I think this one should be. Oh no, I do need something here. I guess somehow, somewhere, I have this one here. So for these, this is a while loop, right? So this is a while loop, and this is a while. I think I need something here, and then do these. Yeah, okay. So let's see that. Maybe some full score, maybe some exceeded. So that simply means, oh, okay, I didn't finish everything, right? So this is if, right? And then I have else if, else if, else if. So if x is bigger than, okay. So for these, I also want to have maybe cur s, cs equals all of these, right? Okay, so this is just being lazy, okay, for these. So now I need to make a decision here. If x is bigger than that, what does that mean? So that means x minus a cs is bigger than 0. So that is simply means that simply means what? That simply means cs is a too big, right? Is a too big. Therefore, I need to push right backward, right? Okay. So that simply means r minus minus, right? Okay. And then whenever you finish these, the opposite is going to be pretty straightforward, just a plus plus, right? Plus plus here. And then also you do need to have L plus plus and R minus minus here, right? Okay. And then let's see what is going on here. Okay. So, okay, now we have three good cases here, right? Okay. So I do not memorize the solution. Okay. I never memorize the solution. But something I want to memorize is the big picture. The big picture, I do need to memorize it. And I'm using my logical thinking to push it forward. The reason why it's very important is, I mean, you don't want to memorize it because if you memorize it, there's no way to solve another question. So therefore, this is very important. So, and it's very okay to make mistake. I mean, in the first round or second or third times. But unless your logic is on the right track, that's the most important thing. If I submit, I think there's still some problem here. Maybe one last case or something here. Mm, and then maybe just something I need to trim it a little bit, right? Okay. So I have -2 this one, but this one is offset, right? If this offset, maybe I need to shorten the distance and then submit again. This is basically in real situation, you probably will be seeing something like that. So you have to keep trim it until it's done. And then you find, okay, I have one data short, right? So therefore, maybe you just add it back, right? Okay. And then next step, you gotta find, okay, what is going on here? Why it doesn't work? Why it works in previously, right? Okay. So now probably is this, right? So we have this one, all right? This one's negative of that, right? So if they're equal, right? Okay, so now let me probably change that into CS here. So what if I do that? If that equals to 0, if that would that be a different stories here? So let's maybe give it a go. So for this part, little part, right? So um, okay, so let's round this one here. X minus cs double equals to 0. That simply means if you that, so you can have this right here. So you have a -1 and that. It seems like is a little this one you add these two, but there is no such one, right? So therefore, I guess there's something wrong with these, right? Okay. So now you can maybe remove that and try it again. So because this is probably very suspicious stuff here. So the range of stuff, okay. And if you do that, you simply skip that, right? Okay. And then what do you need to do? So you got to ask yourself, so this is a one, okay, so you want to put a flag here, right? So this is a one flag, all right? And this is also another flag. Um, because in the real examination, right, you don't know which one is going to work. So you have to test different situations here. So this is a very suspicious step here. So either the range or I mean checking the distance here. So for instance, the CS, right? CS is this is set here. And this one is going to be the current one. So the current one is a negative. So I think probably, all right, so it's going to be this. So x is a negative. Negative, no, I guess this one is going to be on the other side, right? So if they're the same, so negative and or maybe plus this one is equals to 0. So that simply means you add the two numbers together, right? So let's see that. So then I'm going to turn this one into equal. Therefore, they can actually see each other, right? Okay, without the equal, there's no way for them to see each other, but there's still little problems here. But if I submit that, let's see what is going on here. All right, so then I have a worse performance here, right? Okay, so now I guess the most of the problem is this part and that part, right? Okay, because of these, you just need to push it in, right? And for the Boolean is a sing and auto, you check the all the stuff here and find item. Let's see, what if I change these one into these? Okay, item here. Um, but I guess maybe no, it has to be the box here, right? Okay, and attach to the end and false this one. And if it's not seen, that means it's not in it's not in the box, right? And then we add in. Okay, wait a second. This is supposed to be it. So test have the box and we add it. If there is something, we do not turn it in. And this one is true. If this is true, we do not add in. So yeah, this is supposed to be good. Left the plus plus and x equals this. So x is bigger than that. So we increase that. Uh, so what if I turn this around? Okay, what if I turn this around? Would it be a different story? So let's see. So for this part, you are allowed to test as many times as you want. So simply you just adjusting the result here. Now you have a three good cases here. And then let's submit this question here. Maybe this time a better result, maybe not a better result. Depends on the currency. Now, I guess it's a better result here. So 312, right? Okay. So, and for this part, all right, okay, next one, we need to trim it. So the trim it part is going to be what? I guess we worked on something like the while loop, right? So while, if left is less than right, and the double end, right? Okay. And what is going on? Nums of something equivalent to nums of something. So this is L plus one, and this is going to be L. And we're going to push left pointer L forward. And by doing so, it's just a one code, right? So we're able to optimize the code for that. So this is going to be L, this is R, and let's test it one more time. Okay, there we go. So I think it should be a full score this time, right? There we go. So the reason why I want to show you this is because in the real context, all right, no worry about you got a wrong answer. The most important thing you just need to you keep doing it. You keep testing, all right? You don't stop. You don't stop until you get the correct answer, all right? So as you can see, so I didn't stop, right? Even though I got a worse result, right? I didn't stop. Instead of stop doing it, I've tried to ask myself why it doesn't work. Is there anything I can optimize my solutions, or there's any bugs or something wrong, right? Okay. And apparently, so there are something wrong here, right? So this one and that one. And I also want to check if I turn that into equal, what would happen? So let's see. So there's not good, right? So they're supposed to be not equal here, right? Good. Because if they're equal, they're checking the same number, right? They're checking the same number. So it doesn't make any sense. So this is always going to be less than. For this part, right? So this part, you can just say x equals to cs. So that means it's exactly the same number. So that is also no worry about it, right? Okay. For these, you just need to memorize it, right? Okay. And of course, in the real context, if you forget these, you're welcome to check your old notebook here because this is not this is not algorithm stuff. This is just the memorization. You just need to memorize. Okay, by using this code, I am able to check the duplicated data. Uh, and then, all right, for these, okay, so if x is less than cs, right? So that simply means you move this one over here, and that is less than 0, right? Okay, this is less than 0. If it is less than 0, that means the cs is, yes, cs is too big, right? CS is too, no, that means, okay, so that means CS, x minus that is less than 0. That means, oh yeah, yes, that means yeah, CS is too big, right? CS is too big. If that's too big, we need to move it to right, R to left, right? Okay, that simply means minus minus, right? So if you cannot convince yourself, 2 minus 3 less than 0, right? Okay, less than 0, right? And CS equals, you can say maybe 1 plus 2, right? Therefore, or maybe it's L plus R, right? And L is always less than R, so therefore R minus minus, right? Okay, I guess this makes sense. And anything else is very easy, so it's just the opposite. Okay, so for this part, if you are not so sure whether it's going to be less than or plus plus minus minus, do this, all right? You can simply use some constants, all right? 2 minus 3 less than 0, right? That means this one is too big. And then you are going to shorten these numbers value, right? There we go. This is the way you can set up your algorithm. If you're not so sure, just use a constant to test. This is a little trick. Makes sense, right? Good. Okay. So now I'm going to forward the code to you. This is too big, so I'm going to forward it through the Google Docs here. Okay, there we go. Good. Okay. So right now I want you to go over this question. All right. So walk through these line by line, and later on, let's see if you can solve this problem at your end. By by implementing the logical thinking line by line. And then you can also draw some visual diagram, like a hopping I to J, blah, 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 to demonstrate. And and you also want to talk, right? You talk while you are programming, just like the way I did, all right? I didn't stop talking, right? I started to talk while I was programming it, right? Okay. So yeah, it's just been 30 minutes. I keep talking. Okay, so and you want to keep talking as well while you are programming it. All right. Okay, good. So now I'm going to stop